Hello students, today we are going to start with a new topic and that is the binomial expansion. Now, as you know, bi means 2. So in binomial expansion, we are going to expand the brackets which have two terms like a plus b to power n. Okay, you are already familiar with the concept of coefficients. Now, take for example, I have a term here 3x square y. So in this term, this constant 3 with the term that is called as the coefficient. So today we are going to study something called as Pascal's triangle. Now Pascal's triangle gives the coefficients in the expansion. So to understand this, let us see some expansions in order. First is a plus b to power 0. Now as you know already, anything to power 0 is 1. So I'll just write 1 here. Then the next expansion is a plus b to power 1, and anything to power 1 is the same thing. So I'm going to get a plus b. So the coefficients here are 1, 1. So I'll write here 1, 1. Now you have already studied the expansion of a plus b square, and that is a square plus 2ab plus b square. So the coefficients are 1, 2, 1. So here you can see one pattern. Now in each row the ends are 1, and if I add this 1 and 1, I get 2 that I am writing in the middle in the next row. So if I continue like this, the next row will be 1, 3, 3, 1. And these are the coefficients in the expansion of a plus b the whole cube. Now how to write this expansion? Now see, some generalization I can make here. Now in this bracket, the first term is a. So when I expand, first term becomes a square. So the first term in the bracket gets the full power. In the next term, h's power is reduced by 1. It has become 1 here. And I have introduced b. So b's power is just 1. So like that, in each term, I am going on reducing h's power by 1 and increasing b's power by 1. So keeping that in mind, the first term will be here a cube. Then the next coefficient is 3. I'll reduce h's power by 1, introduce b here. Then the next coefficient is 3. Again reduce h's power by 1, increase b's power by 1. And finally, in the last term, the coefficient is 1. So b will have the full power, b cube. So the expansion of a plus b the whole cube will be a cube plus 3a square b plus 3ab square plus b cube. Now, if I continue like this, the next row will be 1, 4, 6, 4, 1. So that means the expansion of a plus b to power 4 will be, first term will be 8's full power, a to power 4. Then the next coefficient is 4. 8's power I will reduce by 1. Introduce b here. The next coefficient is 6. 8's power I will still reduce by 1. B's power I will increase by 1. Next coefficient is 4. A, b cube, and in the last term b's full power, that is b to power 4. So this is how, using the Pascal's triangle, I can write some of the expansions. And Pascal's triangle will be useful up till the power say 6 to 7. For higher powers, there is general expansion, binomial expansion, that we'll see afterwards. So let us just write this Pascal's triangle up till the say power 6. So the next row is 1, 2, 1. So this gives the coefficients in the expansion of a plus b the whole square. Then 1, 3, 3, 1. That is the coefficients in the expansion of a plus b the whole cube. Then 1, 4, 6, 4, 1. Coefficients in the expansion of a plus b to power 4. Then 1, 5, 10, 10, 5, 1. Expansion, coefficients in the expansion of a plus b to power 5, and then the coefficients in the expansion of a plus b to power 6. 1, 6, 15, 20, 15, 6, 1. So the ends of each row are 1 each, and when you add any two coefficients in any row, you get the coefficient in the next row, and that you will write in the middle of the two. Okay, so this is the Pascal's triangle. So let us do some of the expansions here. Let us do some problems here. So first one, take 2a plus 3 to power 4. So what are the coefficients from the Pascal's triangle in the expansion of a plus b to power 4? 1, 4, 6, 4, 1. So the first term 2a will have full power 4. Then the next coefficient is 4. I'll reduce 2a's power by 1 and introduce 3 here, that is your second term in the bracket. Then next coefficient is 6. I will reduce 2a's power by still 1, so it will be 2 here, and 3's power I will increase by 1. Then the next coefficient is 4. 2a's power I am reducing by 1. 3's power increase by 1. And then finally in the last term 3 will have the full power 4. One more thing you can see here. If I take any term and take the total power of the two terms in that particular term, it will be always equal to the power of the bracket that you are expanding. Like here, take for example this term, 2a's power is 3, 3's power is 1. So total power is 3 plus 1, that is the power of the bracket that you are expanding. Now, and one more thing, when this is expansion in the form a plus b to power 4, there will be 5 terms. So number of terms will be always one more than the number of power of the bracket. Take for example, if the expansion is in the form a plus b to power 10, there will be 11 terms. Now expand this 2 to power 4. See, when you are doing this expansion, I'm just writing in the rough here. So it will be 2 to power 4 into 8 to power 4. So 2 to power 4 is 16, 8 to power 4. In the second term, 2a cube, that will be 2 cube, that is 8 into 4 into 3. So you can do this on the calculator. That will be 96a cube. Okay, but don't forget to take the cube of 2 also. So 4 into 2 cube into 3, that is 96. In the next term, 6 into 2 square into 3 square, that will be 216 a square. In the next term, 4 into 2 into 3 cube. So that will be again 216 and here a. And finally 3 to power 4 is 81. That is your final expansion. Let us take one more problem here. Take this one, 3a square minus 1 to power 5. Now here, the middle sign in the bracket is negative. So first I'll write it in this form, 3a square plus negative 1 to power 5. And in the expansion of a plus b to power 5 from the Pascal's triangle, what are the coefficients? 1, 5, 10, 10, 5, 1. So that is 3a square to power 5. Then the next coefficient is 5. 3a square to power 4, and here introduce negative 1. Then the next coefficient is 10. Reduce 3a square's power by 1 and increase negative 1's power by 1. See, the total power should be 5. So here 3 plus 2 5, in the previous term 4 plus 1 5. Then the next term. So again the coefficient is 10. 3a square, the power will be 2, and negative 1, the power will be 3. Then the next coefficient is 5. So 3a square, the power is 1, negative 1, the power is 4. And in the last term, negative 1, power 5. Okay, now simplify this. 3 to power 5, that is 243. And keep this in mind, this is a square to power 5 in this bracket. So use the laws of indices. So 2 and 5 will get multiplied. It will be a to power 10. Now in the next term, positive into negative is negative. So the next term will be negative. So 5 into 3 to power 4, that is 405, and a square to power 4, that will be a to power 8. In the next term, negative 1 square, that will be positive 1, so the next term should be positive. 3 cube is 27 into 10, 270, and a to power 6. In the next term, negative 1 cube is negative 1, so this sign will be negative. 3 square is 9, so this will be 90, and 8's power will be 4. Now in the next term, again the sign is positive. Negative 1 raised to 4 is positive. So here 5 threes are 15, a square, and negative 1 raised to 5, the last term will be negative 1. So that is your expansion here. So I will give you some problems for practice. Try these expansions by using Pascal's triangles. Pascal's triangle. So the first one, 2a plus 5 raised to 4, 3a minus 2 cubed, 2m square plus 1 raised to 5, and 3m square minus 2 to power 6. So just try these problems yourself by using Pascal's triangle. Which the steps are okay with you. So if any doubts are there, we'll go through them in the next class. Thank you students. Enjoy the day.